Hello viewers, welcome to my channel and thank you for watching the video. In this video, question 6b of 1997, integrating e to the power minus z square along a suitable rectangular contour, show that integral 0 to infinity e to the power minus x square cos 2 bx dx is equal to under root pi upon 2 e to the power minus b square. So this type of question we have to remember a little bit how to start, because it's a typical type of question. Contour is rectangle given, so we will take this contour A, B, C, D. Contour is A, B, C, D and x is minus r to r and y is 0 to a. So here it is 0 to infinity integral. If we see integral is 0 to infinity and suitable contour we have to take, so we are taking this. Y is equal to 0 here, y is equal to a, x is equal to r, x is equal to minus r denoted by tau. So here we will be starting 0 to infinity integral e to the power minus lambda x square. Lambda is equal to 1 will give the result, and cos 2a lambda x. So if we put a is equal to b and lambda is 1, then we will get the result. So that is why I said that we have to remember how to start and which type of contour will give us directly the result. Fz is equal to e to the power minus lambda z square. We are taking minus lambda x square. So Fz we are taking it is z square and the contour is tau. The rectangle I have already explained and it is anticlockwise. Since e to the power minus lambda z square is an entire function means it is analytic or holomorphic over whole complex plane, means there is no singularity, means there is no pole. So this function has no poles, and generally we see that exponential trigonometric functions, these are entire functions. So integral of this over closed contour is tau here, which we have taken, is equal to 0. This is by the theorem Cauchy's integral theorem, Cauchy's theorem. So we get this is 0. Now we compute integrals along the four sides. So what will we do? We have taken that contour which is a rectangle and it is anti-clockwise. The rotation is anti-clockwise from here to here, and we have started from A to B, B to C, A to B, B to C, C to D. So on vertical lines B and C and A and D, we compute, because we have to compute over four sides. So B to C, Z is capital R plus IY. Z is X plus IY. So R is X here. We have taken minus R2 plus R. R is very large number, but it is a number, so it is a constant. When we differentiate, we get dz is equal to I dy. So when we put in the integral, it becomes BC over BC e to the power minus lambda z square dz is equal to 0 to a. Because y is 0 to a, which we have taken, it is minus r0, this is r0, this is ra. So y is a. And we know the theorem that if fz is integrable along a curve C having finite length L, and if there exists a positive number m such that mod fz is less than equal to m on C, then we can write mod of integral C fz dz is less than equal to ml. Or we can write down further, we can see that mod of integral C fz dz is less than equal to integral over C mod of fz into mod of dz. So same property we are using here. This is mod of integral fz dz over bc is less than equal to, if we open it, it becomes e to the power minus lambda into r square plus I square y square plus 2I ry into I dy. So when we see the mod of each term, it becomes e to the power minus lambda r square we have taken common, and 0 to a integral is there, e to the power minus lambda I square y square, which gives e to the power lambda y square. Mod of I is 1 into, there will be another term, into e to the power minus lambda 2i capital ry. Mod of that will also become 1. So we have this much, and in this is constant, the term which is integral 0 to a e to the power lambda y square dy. This is basically is of the form e to the power x square dx integral. In this case we have, if x square suppose is equal to under root lambda y whole square, so we can write with the help of the series 1 plus x square, that is exponential series. We can expand plus x to the power 4 upon factorial 2 plus x square to the power cube, that is x to the power 6 upon factorial 3, that is 6, and so on dx. When we will integrate term by term, when we put the limits, it will be a constant, though very large number, but it is a constant. And similarly we know another way to do it, that is integral of e to the power x square dx is equal to under root pi upon 2 error function I x, that also. So but we are writing it as a constant and into e to the power minus lambda r square. And when r is very large, the whole term becomes 0. This tends to 0. So integral bc e to the power minus lambda z square dz will be 0 as r tends to infinity. And over dA also it becomes 0 as r tends to infinity. So now there are only two other sides, AB and CD. On AB, z is equal to x because y is 0 here, and we write limit r tends to infinity AB e to the power minus lambda z square dz is equal to minus infinity to infinity, because we are going from left to right, e to the power minus lambda x square dx. We will integrate another side is CD, in which direction is anti-clockwise, and we are moving from plus infinity to minus infinity. So we write integral CD limit r tends to infinity e to the power minus lambda z square dz, minus is on top because we are moving from positive to negative, that is positive infinity to minus infinity negative, e to the power minus lambda x plus ia whole square dx, because on CD z is equal to x plus ia. So here we write, just open the expression and put minus sign and reverse the limits. So this becomes, we have in with minus sign e to the power minus lambda x square minus a square, because I square a square is minus a square, into this term, which can be written in terms of cos and sine. So cos 2a lambda x dx plus I minus infinity to plus infinity, and e to the power minus lambda x square minus a square sine 2a lambda x dx. This we can write. Now we have the whole integration is equal to 0 when it is over tau, and when limit r tends to infinity, integral tau e to the power minus lambda z square dz, which we have divided into 4 parts. This we have written 4 parts, in which 2 parts are 0, which is BC and DA. So remaining are first and third part, and first part is this much and third part is this much. So from here minus e to the power minus lambda square has been taken common, because this minus minus will become plus, and integral minus infinity to infinity e to the power minus lambda x square cos 2a lambda x dx plus I e to the power lambda a square and e to the power minus lambda x square sine 2a lambda x dx. Now we equate the imaginary and real parts. So imaginary is this much because I is here. So only one term is imaginary. This we will put equal to 0. And this is the real part. Rest two terms are real. So when we put them equal to 0, they become equal to each other. So we do that. Now after comparing, we can write down first imaginary part which is equal to 0, and then real part which gives two terms equal to each other, which we have. Now here we see it is minus infinity to infinity. This term we will consider later on, multiply. Just focus on this. Minus infinity to infinity e to the power minus lambda x square dx. So if we multiply it by 2, it becomes 0 to infinity. And we have kept capital X is equal to under root lambda x. Basically this is e to the power minus x square dx type of form. So here we have, if limit e to the power 0 to infinity, then we can integrate it. Otherwise, if it is positive, we were having error function, or we have to. The same thing here also we can do, that we can expand it and then can integrate, but here we put a capital X is equal to under root lambda x. It gives dx is equal to under root lambda into dx. So in small dx is equal to 1 upon lambda d capital X. So this is written here into e to the power minus x square 0 to infinity. Now we do another substitution, that x square is equal to t. So this gives 2x dx is equal to dt. And from here we get capital dx is equal to dt upon 2 into capital X, means dt upon 2x, which can be written as dt upon 2 root t. dt upon 2 root t. This is the expression. So this 2 will cancel out with this 2 which we have written outside, which will cancel out, and inside we will have integral 0 to infinity and e to the power minus t, and of course lambda minus half is here, lambda to the power minus half is here, and into t to the power minus half, t to the power minus half dt. And if we compare it with gamma function, so gamma function is gamma n is equal to integral 0 to infinity e to the power minus t to the power n minus 1 dt. So if we compare, it gives here that n minus 1 is equal to minus half. So n is equal to half. It means it is equal to gamma half, and gamma half is equal to root pi. So root pi into lambda to the power minus half, which was there here. So this is the integral of this. We multiply it by e to the power minus lambda a square. So this comes this much. That is because we were writing this is 0 to infinity e to the power minus lambda x square cos 2a lambda x dx is equal to 1 by 2 of this much is equal to 1 by 2 of this much. We have substituted the value of minus infinity to infinity, which we have calculated here, and which gives us the result.